Right, firstly, what is the relative formula mass of calcium hydroxide? Well, you need to know what calcium hydroxide is first. So calcium has two arms. Hydroxide is a polyatomic group with one arm. So you're going to join those up, and you're going to get Ca bracket OH2. So that is going to be, if I take a look at the periodic table over here, I can see that calcium has got a molar mass of 40. And that means that I can say 40 plus oxygen has got a molar mass of 16 and hydrogen 1. So that's going to be 17 times 2, which is 34, because it's 16 plus 1, 16 plus 1, and that turns out to be 74. What is the molar mass of sulfuric acid? First, we need to know that sulfuric acid is H2SO4. Then we go 2 plus 32 plus 4 times 16, and we land up with 98. What is the relative formula mass of lead 2 nitrate? Pb, sorry, it's not lead 2, it's lead 4. 1, 2, 3, 4. Nitrate, NO3. In a group, keep holding hands. And another one, and we land up with Pb, bracket NO3, 4 of them, so that's 207, plus 4 times 14 plus 48, 3 times 16, and I land up with 455 altogether there. The next one is, what is the molar mass, or molecular mass, which is the same as the molar mass, of ammonia. So I'm going to go, what is ammonia? It's NH3, which means that I go 14 plus 1 plus 1 plus 1, and I land up with 17. What is the relative formula mass of aluminium oxide? Again, I'm going to have to work out what the heck aluminium oxide is before I get to work that out. So aluminium has got a valency of 3 because it's in group 3. Oxygen has a valency of 2. And I have Al2O3. Adding that all up, it's 27 plus 27 plus 48, and I land up with 102. What is the relative formula mass of tin 2 chloride? So if I'm going to now take tin, I've got 119, or sorry, first tin 2 chloride. I need to know that tin is SN2, chloride, valency 1 because it's in group 7, and therefore I get SnCl2, so it's 118 plus 35,5 times 2, which is 71, and you land up with, sorry, this is 119 over here, it's 118,71 on this particular table here, and so you land up at 190. How many moles are there in 94 grams of sulfur dioxide? So number of moles is equal to mass over molar mass, which is therefore going to be equal to, the mass they've given me is 94. The molar mass of sulfur dioxide, again, SO2, 32 plus 2 oxygens is another 32, so I land up with 64, and I say 94 divided by 64, and I land up with 1,47 moles. So zinc is 63,5, sorry, I think 4 actually, and you land up with 35,5 times 2, and you're then going to land up with a molar mass over there of 134,4, and then you get 1,65 moles. How many moles are represented by 14 grams of lead 1 nitrate? So you're going to have to say lead is 207. If it's lead 1 nitrate, you're going to actually just have PbNO3 because it's 1 lead to 1 nitrate, and therefore that's plus 14 and 48. And you land up with the mass that they gave me, 14 divided by 269, and you get 0,05 moles. At STP, how many moles of gas are present in? So I'm given a volume now. So now we're going to say number of moles is volume over molar volume. And so you're going to land up with number of moles is equal to 4,2 decimeters divided by 22,4, which is 0,19. Then if I'm going to take a look at how many moles of gas are present in 13,4 decimeters cubed, again, it's just volume, 13,4, divided by molar volume, 22,4, and I land up with 0,6. How many moles are there in 71 grams of chlorine? Now, 71 grams is a mass, so you now need to go back into mass over molar mass, and that is going to be 71 divided by 71, and you land up with exactly 1 mole. At STP, how many moles of gas are present in a certain volume of nitrogen 4 oxide? And I'm back into the number of moles is volume over molar volume. So it's 29,7 divided by 22,4, and you land up with 1,33. How many particles are there in 200 grams of silver nitrate? Silver has a valency of 1. Nitrate, NO3, has a valency of 1. So I'm going to need to work out the molar mass of silver nitrate, which is equal to 108, sorry, not 180, 108, plus 14, plus 3 times 16, which is 170. And then we're going to say number of moles is equal to mass over molar mass, which is equal to 200 divided by 170, which is equal to 1,18 moles. But that's not the question. They want the particles. Number of particles, now we're looking at this triangle. Number of particles is equal to number of moles times Avogadro's constant, because we're looking for number of moles, so that is your answer. And you're going to go 1,18 times by 6,02 times 10 to the power of 23, and you land up with 7,08 times 10 to the 23. How many particles are there in 445 grams of nitric acid? Number of moles is mass over molar mass, 445 divided by, what is the molar mass of nitric acid? 1 plus 14 plus 3 times 16 gives me 63, so I go 445 divided by 63 gives me 7,06 moles. But that's not the question, it's how many particles. So again, I'm using number of particles is equal to number of moles times Avogadro's number, and I land up with 7,06 times by 6,02 times 10 to the 23, and that's equal to 4,25 times 10 to the 24 particles of whatever I worked out the molar mass of. HNO3. This becomes relevant in the next couple of questions. How many particles are there in 1,5 moles of hydrogen chloride? Well, this could not be easier. You're just going to say number of particles is equal to number of moles times Avogadro's number. And I land up with number of moles being 1,5 because they already gave it to me, easy peasy. And it's 6,02 times 10 to the 23. And that turns out to be 9,03 times 10 to the 23. The next three are the ones that are slightly challenging. They're going to ask me how many atoms there are in 14 grams of sodium hydroxide. Well, the first thing I'm going to do is I'm going to work out how many particles there are. So I'm going to go through the same motions. Number of moles is mass over molar mass. It's 14, and in this case, I'm going to work out the molar mass of sodium hydroxide, NaOH. That's equal to 23 plus 16 plus 1, which is equal to 40. So I go 14 divided by 40 is equal to 0,35 moles. I then say how many particles have I got? Number of particles is number of moles times Avogadro's number, 0,35 multiplied by 6,02 times 10 to the 23. And I land up with 2,1 times 10 to the power of 23, which is all well and good, but that's not the question. What is that? That is the NaOH particles. But for every one NaOH, how many atoms have I got? Because here I've got a question asking me how many atoms there are. Well, for every one sodium hydroxide, I've actually got one sodium, one oxygen, and one hydrogen, so it's 3 atoms. So I need to take this number and I need to multiply it by 3 in order to get 6,32 times 10 to the 23. Right, now if I am asked to find the number of atoms in a certain volume of ammonia, number of moles is volume over molar volume. They give me 11,2. Molar volume is 22,4. That means I've got 0,5 moles. I now work out the number of particles. Number of particles is number of moles times Avogadro's number, 0,5 times 6,02 times 10 to the 23, and I land up with 3,01 times 10 to the 23 watts. Ammonia particles. Because that's what I was dealing with, but that's not what they ask me. They're asking me how many atoms. So for every one ammonia, which is NH3, how many atoms have I got? I have got 4, 3 hydrogens and 1 nitrogen. So I am now going to have to take 3,01 times 10 to the 23 ammonias and get a ratio, multiply it up by 4, and I land up with 1,2 times 10 to the 24 atoms in that power. Last one. How many atoms are there in 3 grams of copper 2 sulfate? So I first have to go number of moles is equal to mass over molar mass, and it's 3 divided by what is the molar mass of copper sulfate. So it's CuSO4, which is going to be equal to 63,5 plus 32 plus 4 times 16, which is 64. And I land up with 159,5. Plug it in here, 159,5, and I take that and I say 3 divided by 159,5, and I land up with 0,018 moles. Number of particles is number of moles times Avogadro's number, and that's going to be 0,018 multiplied by 6,02 times 10 to the power of 23. And we land up with 1,13 times 10 to the 22 copper sulfate particles. But that was not what I was asked about. I was asked about number of atoms. So I need to say for every 1 copper sulfate, how many atoms have I got? Well, for every 1 I have got 5 atoms. So therefore I need to multiply this number by 5 in order to get 6,79 times 10 to the 22. 2.